I have no desire to go to Houston, Texas for the I'm good. This is the one where it's like, because
all right, happy Thursday. How's everyone doing? We just got an announcement about from the Pitt Police about Barco Law. If anything like that comes up in the future during or like right before class time, feel free to just follow the police instructions. You don't have to be here if the police are telling you not to be. So just for future, just keep that in mind. I got a couple of emails about that. That's the broad answer. Take care of your safety first, and then we will do class secondary. How's everyone doing? You loving the first week? No? It's always, for me, on this side of the room, it's always pretty exciting. I love the first week, getting to know people, but definitely there's like more going on than normal. So if you're feeling that, that's the experience of week one. So what we're doing today, we're just getting started with working with data. Our expectations are pretty low for today in terms of like high level. We're going to be doing a lot of the practical stuff today, just getting set up in Excel and using notebooks. So we're going to start with sort of why we do some of these things first, and then by the end of class today, we will hopefully have made our way to looking at the survey data that we collected last class to get a general sense of what the classroom looks like, just using the information we've collected. So that's where we're going. A couple of housekeeping things at the top here. I posted the homework, which is due on Friday, so that's tomorrow. So you should have access to it. You can find that here. This should not take you more than a few minutes. This is really just a couple of simple questions based on what we're doing today in class. This is a quick turnaround. Like I mentioned last class, if the turnaround ever feels too quick for you to complete with your full rigor, send me an email and you will get an extension, no questions asked, till Monday. So I don't want the turnaround to ever feel like a burden for you, but I also want to give you some incentive to do it before the weekend so that you can have some of your weekend more free. So that's why we're doing a due date on Friday, but I never want the due date to feel like too much pressure for you. So this should take you about 10 minutes. These are just going to be multiple choice questions on Gradescope. You've all been added to the Gradescope page on Canvas or on Gradescope. So you can just go to Canvas and there should be a link there and you just click on it and open it up in Gradescope. Anyone not feel comfortable with Gradescope? Or how many of you have used Gradescope before? I think almost everyone. If you haven't and it's not clear what's going on, send me an email and I can just walk you through it. Or we can talk about it after class. Okay, so this is based on the survey, and you can find the survey data here. So you should be able to download it and look at the survey data. So this will help you answer the questions in the homework. And like I mentioned, it's just multiple choice this week. Really don't spend more than 10 minutes on it. If you're losing your weekend because of this homework, I think you're doing it wrong. All right, so that's the housekeeping. We have homework. We're doing the first exercise today. And then next week we'll pick up with talking about visualizations. So that'll be Tuesday next week. Okay, any questions before we get in? Y'all feeling good? The correct answer is yes. Okay, so at a high level, what we're about to start doing is working with data summaries to understand a data set, which is really the ground truth of what we do in science, or at least a lot of areas of science. To understand a data set, it's much easier when we have visualizations. This is just like stock footage, stock images of some nice visualizations. And what we're going to be doing this semester, especially here at the beginning, is talking about ways of understanding our data. As you'll see, the best way of visualizing our data depends on what the variable type is that we're working with. So we match the visualization to the variable type. What we're doing today is just talking about the different variable types and trying to identify them before we start trying to summarize them. So that's where we're going. You can see a lot of bad visualizations because of a mismatch between the variable type and the tool that we're using. So we'll just talk a bit about the dimensions of data. We're going to talk about, we're going to work through these different dimensions of data over the next couple of weeks. The first one, the one we're starting with today, is variable type. And we can generally break variables into two types. One is categorical data. So these are, I'll give you some examples in a second. But these are, it's like data that can be, as the name suggests, broken into categories. And then the second type is data that can be represented with a number. And there's not actually, like we talk about these different types, but there's a bit of fuzziness in some cases about what is classified as a categorical variable and what's classified as a numerical variable. But we're going to talk through some ways of trying to distinguish these things. So variable type is the first one we'll talk about. In probably next week, we'll talk about data structures. So this is not just what's contained in the variable, but how the individual rows are connected to each other. So sometimes you just go out into the world and you ask a bunch of people a certain thing, a certain question, and you record their answers. This is what we call cross-sectional. I'm looking out into the world and I'm observing multiple people at the same time on the same dimension. So this would be cross-sectional data. And when we get to data structures, we'll talk more about what that looks like. And then we have time series, which is, as you'd expect, just repeated measures through time. So we like, for example, we can measure GDP, just a sequence of GDP measures through time. And then you can, you've all seen those like line plots of GDP with time on the horizontal axis. That's time series data. And we will come to that in a little bit. And we'll particularly talk about this in part 2. And then panel data is a little more complicated. It's when we have repeated observations, so multiple time periods, but we also have multiple time periods across many individuals. So it's almost like we're combining cross-sectional data and time series data into one data structure. So I'll give you an example of this and some nice visualizations a bit later, but it's essentially repeated observations within an individual, but then we have many individuals in our data set. It's the most complicated data structure. We're not going to spend a lot of time on it this semester. I wrote my dissertation using panel data. It's really powerful. There are a lot of reasons we love it. But it's a bit more complicated, and I'll show you why. And then we also have the number of variables. Who put these slides together? Why is this so low? And what we're spending part 1 talking about is univariate data. So it's simply thinking about data sets that have one variable. But then in part 2, we'll start expanding into bivariate data. So we'll talk about when we have multiple columns. And we're going to do about a bit of this in part 1. But we're going to spend the bulk of part 2 talking about bivariate data. And then bivariate data and multivariate data, I just included these 2 bullet points. Maybe I should get rid of this one so it's not so low on the screen. Bivariate data and multivariate data are very similar in the way we approach them. But this is just a way of classifying the number of variables that we have in our data. If you can count, you can find the number of variables in your data set. Okay, so nice. This is just an overview of how we generally kind of classify things. So let's talk about some examples here. Within categorical variables, we have a couple of subcategories. Categorical variables are essentially just data that's best recorded as a category. So a binary categorical variable really just has two categories that you can list. So in this classroom, are you an economics major? Yes or no? In the survey, I didn't ask this question. I asked, what's your primary major? And that's not a binary categorical variable. Although, as we'll see, it is a categorical variable. A binary categorical variable is something that we can record as like a yes or no answer. Are you human? Well, I think I am. At least that's what I'm told. Which is so that's also a categorical variable, binary categorical variable. Data that's recorded best as categories, and there are two of them. Nominal categorical variables are categories that are not able to be ranked. So blood types. How many of you know your blood type? I don't, actually. Okay. Did I tell you I had a child? We have documentation of her blood type, but I don't know mine. So this is not binary categorical data because there are more than two blood types. But you can't really order blood types, right? There isn't like a ranking of them. Colors are kind of the same way. So your favorite color, there's a correct answer. So there's definitely the best one, the best favorite color, and that's blue. Orange is at the bottom. So this is nominal categorical variables. So this is data that can't be ordered. And we'll talk about some examples of this in a second. Actually working with these things. And then ordinal categorical variables. So sometimes data is best recorded as a categorical variable, but it does have an order to it. It's just the scale isn't obvious. So there's not a meaningful scale. So education levels, so we can order your education level in general. And then we can also order like how strongly you agree with something. And then size categories. These are all things that, I guess size categories, you might be able to measure the sizes, right, with a meaningful scale. But for most of these things, there isn't a fundamentally meaningful scale with the categories. And yet, this data is best recorded as categories. All right, so we've done the classification stuff for categorical variables. Any questions about this? Any quibbles? Questions? Quandaries? Quackery? Great. So that's all sort of the way we classify categorical variables. Numerical variables, there are some philosophical issues if you dig down too deeply into this stuff. Numerical variables are just essentially variables that are stored as best as numbers. So, one of the ways we can store numbers is just with discrete numbers, right? So if I'm counting the number of children in a household, you just go through and you count the number of children. It's usually stored as an integer. So this is like 1 through, I don't know, I think some families have had more than 10 children. So, a number as an integer. So my family has one child at this point. We store them as integers. We typically don't store number of children as fractions. Like it's really just integers, right? Number of siblings. These are things that are stored as integers. And the way we think about this as countable numbers with meaningful intervals, right? The difference between one child and two children is meaningful. It's 1. And it's the same interval between 2 children and 3 children, right? So the interval matters when we talk about numerical variables. It's a big part of what defines them, is that the intervals are meaningful. And then we also have continuous variables. So really, these are things that we just measure on the real number line. So household income and US GDP, these are classic things that we measure, which we think of as continuous variables. At base, we can't really measure GDP at a more fine-grained level than the penny. So a penny, in some sense, is the atom of measurement for US currency. And so in some ways, like, we could think of US GDP as a discrete numerical variable if we were measuring GDP in terms of pennies. So when I say that there's not a big philosophical distinction between discrete and continuous numerical variables, that's kind of what I mean. It's like if we measure GDP in terms of dollars or in pennies, fundamentally it is counting. So we're not going to make a big fuss about the distinction between discrete and continuous numerical variables, but I think it's just worth mentioning on day one. Any questions here? We like classifying things for some reason, and so that's what we do. All right, so nice. So I'm promising to you that the variable type matters in the way that we summarize it. And you might already start to see some of the reasons for that. So what we're going to do essentially for the rest of class today is work with data sets. You got my announcement about bringing your computer to class. In general, it's going to be a good idea to do that. Often we're going to pair the lecture with an in-class exercise. We'll do this most class periods. Really, working with data is best learned through practice. So instead of sitting there hearing me blather on about distinctions between variable types, what we're going to do next is actually just get our hands dirty working with the data set. And then I'll show you some examples of visualization for these different data sets, which we're going to start working with next class. Okay, so for these exercises, let me talk you through how to get started with them. So if you go to the course website, you can click on the main page, or you can just, if I were you, I would just pin the course website to your browser for the semester. One of the nice things about having this external website is you don't have to go through, how many of you love Duo Mobile, like logging in with your phone? Nice thing, you don't have to do that with my website. You can just click on it and be there immediately. So part one, we're in, this should say variable types. So you can find the slides we just went through with some of the exercise visualizations for the data sets we're about to work with. Okay, so when you scroll over to exercise 1.0, we're talking about categorical and numerical variables. So what you can do is actually just download some of these data sets. So if you click on this one, it'll open a notebook for you. Don't do it just yet. We'll get there in a second. The first thing we're going to do is download the data set for employment status. So employment's a pretty big deal right now. It's always a big deal. So we're going to work with an example data set of employment status. So if you click on this, it should download into your downloads folder on your computer a data set. And we're going to spend a few minutes just getting familiar with what data sets look like, how we think about them, and how to open them and work with them. So if you click on this, it will, so I'm using the Arc browser, which is maybe a little different than some of the others. But you can click on this. So if you go to, so in my downloads folder, it will have downloaded employment status. If you just look at it, you can see we have the employment status.csv. CSV is just shorthand for comma separated values. When you see .csv, don't get intimidated. Just know that it's a data set. It's just telling us it's a certain kind of format. We're not going to make a big fuss about that for now. If you double click on this, then it will open the data set in the software for opening CSVs that's default on your computer. How many of you have Excel installed on your computer? Okay. And how many of you have not installed it yet? Okay, totally fine. If you click on it, if you're on Mac, it should open Numbers, I believe. And if you're on Windows, it might open something else, which I'm not sure. So if you don't have Excel installed on your computer yet, one of your homework assignments for the weekend is to go to the Pitt Software Center and download Excel. Just get started with it. There's free institutional access if you go through Pitt. Okay, so when we double click on it, it opens in Excel. What we've opened is not an Excel document yet. This is a comma separated value, basically a spreadsheet that's opened in Excel. We'll talk about how to save these files as Excel spreadsheets, which can be helpful in some cases. But for now, we haven't done that yet. This is just a CSV file, your basic data set, opened in Microsoft Excel. And I'm going to zoom in a little bit just so we can look at what's here. For some of you, this might be a bunch of review, talking through what's contained in the data set. For others, it's not a review. So we're going to start, we're starting at the ground floor. So we're just going to talk through some of the details of what we're looking at here. Spreadsheets are broken into essentially like two dimensions. We have rows that go horizontally, and we have columns that go vertically. So each one of these is a row, and each one of these is a column. And the way Excel works is it labels the rows by number and the columns by letter. You can rename both rows and the columns, but this is the default behavior. Now, in column A, we have the household identifier. So this is essentially the header row. So this is household ID. And what you can see here are a bunch of ID numbers for all the different households in our data set. And so if I were interested in row 4 for the household ID, I could find cell A4. So it would be cell A4. That's how we reference these things. And then the second column is employment status. So this is just telling us for the household in that row, is someone employed or is no one employed? So for household D001, no one in that household is employed. For household D002, someone is employed in the house. So we say unemployed or employed. Any questions here? Does this look familiar? Yeah, nice. So if I were looking at this, How many of you think this is employment status is a categorical variable, and how many of you think it is a numerical variable? Just as a quick comprehension check. Hands for categorical variable. Hands for numerical variable. All right, nice, perfect. This is a categorical variable. And we know it's a categorical variable because employment status is best stored as categories. You could store this, if you like, as 0 and 1. So it could be 0 for unemployed and 1 for employed. So we can store it as numbers if we wish to. But it's fundamentally a categorical variable because these are categories. As you can see, the distinction between variables is not black and white. Sometimes there's a bit of fuzz around the edges. But fundamentally, this is a categorical variable. Okay, so we have 3 types of categorical variables. We have binary, we have nominal, and we have ordinal. How many of you think this is a binary categorical variable? How many of you think this is a nominal categorical variable? And how many of you think this is an ordinal categorical variable? Nice. This is a binary categorical variable. There are 2 possibilities, employed or unemployed. And it's categorical. So this is binary categorical variable. And you can see this just by looking at it, but we can be more systematic. So I want to walk you through a bit of the basic operations in Excel. There's a whole lot more, and we're going to talk a lot about operations in Excel. But for our purposes today, classifying variables, we have some nice operations. So if I were to just click on, let's say D3 here, I can just click on it and then enter new information. So I'm just going to write my name. So I've entered new data into the data set. And if I save this, it's going to save to the CSV file that I downloaded. So we're updating the CSV file. There's some other things we can do. One of the most powerful things you can do in Excel is, how many of you have worked with a Excel function before? Nice. So we've got some real pros in the room. If you want to, you can do a bunch of powerful things in Excel, and we will with functions. If I hit equals, I can write down a bunch of functions which will allow the computer to do a certain thing with the data set. One of the things I want to do here, trying to classify employment status, I want to find the unique values in this column. So I want to figure out what this column of employment status actually contains. You can just look through it, and it's pretty easy in this case, but it won't always be easy. I'll show you an example of this in a second. So what I want to do here is just look for unique. So I'm going to just type in equals, which tells Excel that we're working with an Excel function, and then I'm going to write in unique. And just like in mathematical notation, we have a function, and then we want the inputs into the function. So I'm going to use functional notation here, which is how Excel works, with an open bracket. And you can see it's asking for an array. If you can read that. So an array is just a list of data, essentially a list. And so what we're going to do is just define a list in the spreadsheet that we're going to put into the unique function, and that's going to tell us the unique values in that array. So in this case, we can go through and select all of the rows, all of the cells that we're interested in selecting. And in this case, that's B2 through B101. So you can see it's indexed B as the column, and then the number as the row. So I'm going to close the brackets here and hit enter. And that's going to give me a list of the unique values in the employment status. So let's say unique values. Oops. And if we want to be fancy, we could make this bold. So these are all the unique values that are contained in employment status. And just as we've already confirmed, there are two, so it's binary, and these are categories, so it's binary categorical variables. Okay, any questions here? So there's a bunch that we can do with Excel. This is really just to get started actually interacting with data. How many of you have opened a Python notebook before? Oh boy, more than I thought. That's nice. Okay, if you haven't, you're in great company. Remember that figure I showed last class. Almost half of the class is not confident at all with Python. That's the expectation coming in. So I'm just going to hit save. So Command S on a Mac and Control S if you're on a Windows computer or Chrome OS. And then I'm going to close this. Okay, nice. So this is the way we work with data in Excel. Fundamentally, working with Python is very similar. We're going to work with data sets and functions. So what you can do next to get started with working with Python, you can click on this notebook link. So if you go to the exercise 1.0 card and you click on notebook, this will open for you a new tab in your browser. You don't have to install anything on your computer to run Python. How many of you actually have Python on your computer currently? Okay, for those of you who work with Python on your computer and you want to keep working on your local computer, feel free to do that if you're already set up. But in this class, we're going to be focusing almost entirely on working with Python in the browser, which is really nice. Google has this all set up for us. It even has AI integrations, as I'll show you. Okay, so nice. So let's click on this notebook. And if you do this, for you, it may ask you to sign into Google. For me, because I'm already signed in, it'll just bring this up in the browser. How many of you have a Google Drive account? Okay, so I'd recommend getting, if you don't have one, just getting one set up. If you click on this, it'll open it for you, and then you should be able to save this into your Google Drive account under Google Colab. Are you seeing this when you click on the link? Okay, nice. Perfect. So we're just going to do a bit of a Python demo just to get you started with some of the basics with Python, and then we're going to open the data set. And I'm going to show you that working with data in Python you can think of as very similar, almost the exact same operations as you would do in Excel. Except instead of needing to write down all the steps you follow, you just write it down in code. So we'll talk about that in a second, but I just want to walk you through a bit of a Python demo. So, you all ready to go? So one thing we can do in math is define variables. So you often see x as a variable name. So what I'm going to do is just, in Python, I'm just going to define x to be equal to 2. A couple of things before we get started here. These are what we call notebooks. These are broken into different cells. And you can add cells, either code cells or text cells. Text cells are nice. They just allow us to document what we're doing. If you hit command, let's see. If you just exit out of the cell, it'll just show you the text output. These are what we call code cells. We're going to come back to this one in a little bit. I've preloaded some things for you. So we have a text cell just telling us that this is the Python demo. And then right below, I have a code cell, which we can actually execute in Python. And in 2 minutes, you will have executed your first Python code. So the first thing we're going to do is just write out x is equal to 2 in a code cell. And what this is doing is just telling Python that we have some variable, x, and we're defining it to be the value 2. You can hit this play button if you like, or you can hit Command Enter if you're on a Mac, or Control Enter, I believe, if you're on something else. So we'll just hit Enter here, and that defines in Python this x variable. So now we know, now Python knows what x represents. And if I wanted to check what Python thinks x is, I can just go up here and click a new code cell, and then I can enter x into this cell. And when I hit this play button, it spits out for me the value of x. This is how code works. Any questions about this? It's like the simplest demo on day one. We're going to start stacking the complexity here, but this is fundamentally how code works. There's some nuances with how we work with notebooks. So let's say I wanted to redefine x to be a different number. So it's like, okay, I actually think it should be 1. If I go up here and I rewrite this equation, now x is equal to 1. Let's say I rerun this. What do you think this number is going to be? How many of you think it's going to be 2? How many of you think it's going to be 1? You're all wrong. Let's rerun it. It's going to be 2 again. It's still 2. The reason it's 2 is because we haven't rerun the definition for x. Let's rerun it and then test it. So if I rerun this cell after I redefined it from 2 to 1, and then check what the value of x is, we can now see that it's 1. So these cells aren't always implemented. You have to run each one to communicate to Python what steps you're asking of it. And handily, Google Colab will give you a green check arrow if it's a current cell. So if it's run without being edited, it'll tell you that. Okay, any questions here? So just keep your order of operations clear. Usually we just list them in chronological order going down. So let's say I wanted to do some math. So I have x is equal to 1, and let's say y is equal to 2. I'm going to run this cell, and then I'm going to add these two things together, x plus y. It's going to give us 3. So 2 plus 1, I think I learned that somewhere, I'm not really sure where. It's going to give us 3. So we can do mathematical operations in Python very easily. The next kind of thing we can do is with strings. So sometimes we don't want to record numbers, we want to record something else. I'm sorry, I'm a better door than window. So let's say I wanted to write my name down. So let's say I have a new variable. I can call it whatever I want. Let's call it name. And I'm going to, I want to define name to be my name. To create a string variable, so something that spits out text for us, we're going to put parentheses around the text. So it could be these parentheses, these little ones, or it could be the big ones. Either way, I tend to like the smaller ones better. I'm just going to write down Taylor Weidman, just like we did in Excel. And then just to print out the name, I'm just going to write name at the bottom, and that will print it out. And we just run this cell, and just like magic, it prints out my name. Just like with numbers, we can add strings together. So let's say, so I got married in 2022, and my wife's last name is Craybill. Let's say we have last name, so Craybill. And let's say I wanted to just check what it would look like if I took her last name and used my last name as my middle name. So let's say name plus last name. This is just going to print out for us the squishing of these two strings together, which isn't going to look quite right because we don't have a space. So what we could do is just put a space at the end of my name, and that would give just a name if I were to have taken her last name. So we can do operations like this with strings. Another thing we often do is import extra bits of software. So Python comes with all of these basic things built in, but it doesn't come with everything. If it did, it would take forever to load on your computer. So what we do instead is we import the software that we need for the tools that we're trying to use. So one thing we can do in this case, in another example, is import a numbers package. So I had some friends in college who called me Little Tay. That was my nickname for a second. Python has a package called numpy, which is a portmanteau of numbers Python. I don't like writing out numpy every time, so I'm going to rename numpy as np. So I'm going to say import numpy, which is the numbers package, which is going to tell Python to import numpy. But I want to give it a nickname so I don't have to write out numpy every time. So I'm going to say import numpy as np. So just like my friends called me Little Tay, I'm going to call numpy np. Okay, so when we run this, I've now imported the numbers Python package into this current notebook. And I have to run this every time I run the notebook. Just like before, if I didn't define x and y, I would get an error. So for example, if I had z is equal to 3, and I hadn't run this, x plus y plus z, this is going to give me an error because I haven't actually asked Python to define z as a variable. So if I run this, I get an error. Z is not defined. So if I want to use numpy, I actually have to run this cell. Now, what if I'm interested in, how many of you like trigonometry? Weirdly, my research has landed me currently in the world of trig, in like the complex plane. So I'm thinking about angles and such. So let's say we're interested in some angle theta. Let's say theta is like 44.33, and you're interested in the cosine of theta. NumPy has lots of different packages, lots of things you can do and you can explore within the numbers package. But one way we work with packages is with this dot operator, which we're going to do today. So we have, I have NumPy, so I'm interested in different things we can do within NumPy. One of them is cosine. So I want to find the cosine of theta. How many of you think this will print out the cosine of theta? How many of you think it won't? And everyone else abstains. Okay, you're wrong. This will give us the cosine of theta. Float is just a fancy way of giving us a number. So float, don't let it scare you. The float 64, just ignore all that. This is just telling us what the number is. And if we wanted to, we could put print around this, and it'll give us the nicer number. So we found the cosine of this angle. Lots of other things we could do. We could mp.round theta, and this will give us 44. So we've rounded it down. Lots of different things we can do within the numbers package. It's a really powerful environment to live in. And what's more powerful about code than Excel, the reason we as a scientific world use code and not Excel primarily, is because we can reproduce everything we do. When I work in Excel, I have to write, I don't know about you, I forget the steps I follow. So I have to write down every step I do as I go through Excel. And then if I want to recreate my final output, I need to go back and follow the steps exactly. And what code allows us to do is just write the steps down directly and then have the computer run them for us. So we're skipping a step when we use code. That's why it's so powerful. How many of you have heard of reproducible science? When we do good science, we want others to be able to copy it, to check that we're doing it correctly. Code allows us to just systematize that copying, which is really powerful. Okay, so this is Python as a bit of a demo. We're going to become familiar with these things, but I want you to see that this is fundamentally a set of very simple ideas. Any questions about this so far? Okay, so the next thing we're going to do is, just like we did in Excel, when we had employment status, what we're going to do is load this data set and work with these entries. Now, I've given you an import and a file path. So this file path points you, this is like the location on the internet of the data set. It's on my website, and we're just going to go and look for it. This, as you can tell, is a string. The first thing we're going to do is import pandas. Python loves portmanteaus. This is a portmanteau of Python and, panel and dataset. So panel data. But it gives us a nice name. We love pandas. And just like we did with NumPy, we're going to call this PD, so short for pandas. So if you start calling me Little Tay, I have to think about how I would respond to that. So I'm just going to run this cell, which is going to tell us that file path points to my website, concept 1.0, and a folder data. And then we're going to import the pandas package. Okay, and then I'm just going to scroll down here, and we're just going to read off what this is telling us. PD, you remember, is just pandas. And then within pandas, it has a read CSV. So you'll remember that employment status is a CSV file. So this is just saying, we just want to read the CSV file. We want to open it in the Python environment. Go out, open it, and in the Python environment. And then within the brackets, we're telling Python where to look. So the first place to look is on my website. So we have file path. So we're looking at this string. And then we just want to add, just like we added Craybill to the end of my last name, we're adding employment status.csv to that file path. So we're just squishing those two things together. Look on my website in the data folder, look for the file employment status.csv. That's what this is telling us. And then once we do all of that, we're going to, just like we defined X, we're going to define employment as that data set. So instead of storing a variable as a number, we're storing employment with a data set. So I'm going to run this. How many of you were able to successfully run this? Try this, make sure you're not getting an error, and then we'll check back in about 15 seconds. Check with someone next to you that you're not getting an error. All right. So let's just check what's inside employment. And the way we can do this is just write employment into the cell. So we have employment. And then I'm just going to run this cell. And when we do that, we get a spreadsheet, technically called a data frame, that looks exactly like what we have here. So we have household ID and employment status. And that's just shown for us here. This shows the whole thing. We're missing a bunch of rows in the middle, just for ease of viewing. If we just wanted the top 5 rows, Pandas has a nice little function called head. So we can just do employment.head, and that will print off the top 5 rows. And so you can see we have the same top 5 rows. We have household ID 1 through 5, and we can see each one of these households' employment status. Okay, so our question is what this data set, what the variable type is for employment status. What we can do here is exactly as we did in Excel. We can find the unique values for employed and unemployed, for employment status, using some unique operator. So all I'm going to do is just create a new code cell, and then I'm going to ask Python to find all of the unique values in the second column. So if I want just one of these columns, I'm going to go to employment. So I'm going to tell Python to look in the employment data set. And then we have this notation for looking at employment status, but for each of the columns. I'm just going to write out employment status. And you can see Python sort of already anticipates some of the options here, the different column names. So if I write this out, this is the notation for selecting a column in the data set. So if I run this, it just gives me the single column and not the entire data set. Now, I want to find all of the unique values that are in this column. So what I can do is just add a dot operator and then write out unique. So if I run this, I'm going to get all of the unique values. It tells me what's inside this column. The next thing we might want to do, we can do this in Excel too, but it's even easier to do it in Python, is we can write out, we might want to find the different counts, like how many people are employed and how many people are unemployed in this data set. So I can give you the code, you're going to run it, and we're going to check our answers together. So I'm going to write employment, and then you can see that AI has given me some code that it thinks I might want to run. And in this case, it actually is what I want to run. So I'm going to hit tab twice, and it's going to give me this code. This is Google Gemini predicting what I might want to be writing in code. And I recommend you get familiar with when these kinds of things are nice and when they're not nice. At the beginning, try writing most of your code yourself. Keep the training wheels on. But eventually, you should be familiar with AI tools, which would be very helpful later. But the thing I want to do is just count the different values in employment status. So what you're going to do is run this and then check with your neighbor how many people in this data set are unemployed, and then we'll check back together. Take maybe 30 seconds here. Okay, how many of you got this number for unemployed? 49. Anyone get something different? Nice. So we've identified that this is a binary categorical variable. There are two categories, so it's binary categorical. And then we've gone through and counted how many occurrences for each one of the categories. And we've done this in 2 lines of code. These are very simple operations. Okay, so nice. So this is these are some of the basics with working with data. This is how we essentially get started thinking about Python and thinking about Excel. What we do in Python is identical to what we, or at least very close to what we do in Excel. If you think about the operations we perform in Python as essentially just running operations on a spreadsheet, that's personally how I think about it too. It's just when we work with Python, we can do it systematically, and we can make more sophisticated operations on the data set. Okay. So the next thing we're going to do is I'm going to take the training wheels a little bit further off. I'm going to have you classify the next data set. So I want you to find a couple other people around you. Once you've worked with employment sector, so we can go to the exercise 1.0, and there's the employment sector data set. I want you to download this or work with it in the notebook, and then classify what variable type it is. Let me write out the location for the data set. So this is data set 2, and this is employment sector, and then we'll just call this sector. So I'm going to define a new variable sector, which is a new data set, and then this is just employment sector. So we're going to look in the same data folder on my website, but just employment sector, and I should be able to load this. Okay, so you can do it either way, either in Excel or in Python. We're going to take maybe 2 minutes here, download the data set or load it, and then we will try to classify, using whatever approach you like, classify what the variable type is, and then we'll report back.
Okay.
So we have to do like all of this with the employment sector?
Yeah. Yeah, you can do it either way, either with the value counts or week. Yeah.
Did you get the header of the data set to element sector up there?
Oh, the header?
Yes.
Yeah, yep. So to get a header like that, you can just go in and click on text. And then, yeah, so this is what we call Markdown. It's a little bit, we don't need to get into the details here, but you can just do, if you do one hash, then it's very large. And then if we do 2 hashes, it's smaller. 3 hashes is smaller still, and so on. So different sizes, essentially. But we don't really need to worry about that so much.
Okay, thank you.
Okay, it's been about 3 minutes. How many of you think this is a categorical variable? Okay, nice. How many of you think it's a numerical variable? Okay. Within categorical, how many of you think it's a binary categorical variable? What about nominal categorical variable? And what about ordinal? Okay, someone tell me why you think it's a nominal categorical variable.
So for one, it's categorical because you can put them in categories. They're not numbers.
Yeah.
And it's nominal because it's not like some sort of regression where it would be ordinal, where you could put them in a specific meaningful order.
Yeah.
And it's not binary because there are more than 2 options.
Nice. So it's unordered, and there are more than 2 options. So it would be nominal categorical. Okay, so let's just show this on screen here. So we have sector, and just to look at this, you can see it's like we have all these IDs, and then each one of these sectors. So this one's pretty easy to see just by looking at it, what kind of variable it is. But I want to be a little more careful and actually select all of the unique values. So I can use unique. Whoops. Let's do sector. And that'll get me all of the unique values in that column. And if I wanted to be even more comprehensive, I could write out count values. Whoops. Value counts. So we get the different counts by manufacturing or by employment sector. And this is going to be very useful for us when we turn to visualizations. We like to know the counts. It gives us not just an insight into what's in the data set, but how frequent each one of the categories is. So we'll talk about ways of visualizing this next time. But for the sake of time, I'm going to have you go through the rest of these different data sets on your own. I have 3 listed on the course website. So we have employment status and employment sector, which we've already done. You can look at economic optimism just by clicking on this and downloading it. But you can also look at the other 2 in Python. So if I wanted to open this one, I'm just going to replace employment sector with household size. So it's just the same thing as sector, but I just replace the file name. So call this size. And that's going to load the household size data set. So you can play around with these things on your own. Now, if I have time, I'll upload a video recording of thinking these things through. So this is data set 4. And so you can go through and play around with each one of these. Your homework will involve classifying the survey data that we collected last class. What I want to do here at the end is talk about some visualization techniques, which we're about to turn to next class. So we've talked about, thinking about the different classifications of data, the different variable types. The reason we care, we spent a lot of time today in the details of actually working with data directly. The reason we care about classifying our variable types is because the ways we summarize each variable type is very different. I'm going to show you some examples starting next class with these data sets. But in the last 15 minutes, I just want to talk through the results of the survey. It's for this class and also for another one I teach. So if you want to follow along, for your homework, you can go to part 1, scroll on over, and you can download the class survey data, which will download that for you. You can also open the notebook if you want to do this in a collab notebook. This link, I'm going to have to fix this. Let me come back to this in a second. But for today, you can click on the notebook link here for the class survey, and you can click on the data to download the raw data from the survey. So if I click on this, it'll bring us to the welcome demo. So I just want to get to know you all in a systematic way. Maybe it feels a little impersonal. But I'm going to learn some interesting things about you in the next 15 minutes. So let's just talk through these things. So I have a bunch of imports here at the top. I have a pointer to where on the internet the data set lives. So I'm just going to run this, and then I'm going to load this data. And I'm going to fix this link while we're at it. Oops. Okay. So I've loaded the data set, and we can see all the different columns here. I've done a little bit of data cleaning just to make things simpler. So if you wrote, I think someone wrote baby blue as your favorite color. Unfortunately, I turned that into just blue. I'm sorry. So what we're going to do is just walk through and think about some interesting things about who's here. The first one, let's just look at birthdays. So we have our data set, and if I wanted to get all the columns, I can just print that out directly. So we have columns, I can print them all out. Your birthday is sort of a complicated, you can see in the data set, birthday is pretty complicated. There's a lot going on here. So what I did is I simplified it down to birth year. So what we're going to do is just plot birth years. We're going to spend a lot of time talking about visualizations. I'm going to show you a bunch of visualizations today as a way of introducing each other through data. You don't need to be able to follow all of the things I'm about to show you. For the first birthday example, I just want to plot this as a histogram. So I want different years plotted with frequencies. So I'm going to use Seaborn. So we have this package called Seaborn, which is a very nice data visualization package. Its nickname is SNS. And then I want a hist plot. So I want to create a histogram. So I'm going to write hist plot. And then I'm going to say the data is data. And then I want the x variable to be, so on the horizontal axis, I want to plot when is your birth year. So I'm just going to put this in, and we'll run this. Now, this is a reasonable plot, but I actually just want to have the years between, so Gemini thinks I want all the way back to 1900, but I actually just want 2000. So I'm going to run this, which gives us all of your birth years. So in this classroom, most people are born right around 2005. How many of you were born in 2005? Nice. Yeah, so the plurality, the largest group was born in around that year. Okay, and we could do the same for birth months if we wanted to. There's some more interesting things we'll do later. How confident are you in... Actually, let's do primary majors. So this is your major is a categorical variable, so a hist plot is not going to work. What we want is a box plot. We're going to talk about the nuances here. This is just an example of what we're doing. We want a bar plot. So I'm going to do S&S. We'll do a count plot, which is Seaborn's way of doing a bar plot. Data is equal to data. And then I'm going to put the different categories on the vertical axis. So I'm going to use y is equal to what's your primary major. And this is just going to go through and count up for us all the different categories. So here we have the list. Economics is by far the largest group, but we have lots of other people in this class. This is not just for economics majors, but it's in the economics department, so we get a lot of econ majors. We see a lot of finance, like we talked about last time, and other. The ones, for my purposes as the instructor of this class, I have a lot of interest in how confident you all are feeling in some of these tools so that we can not go too quickly if it's too difficult. So one of the things I'm interested in is how confident you are in Python. So this is, if we just look at this data set, how confident we are. These are numbers. So I can use this with a hist plot if I wish. So this is, we can use a histogram, which we'll talk about in a second. In I should say a couple of class periods. So we can do a hist plot, data, and then x. How confident are you in Python? And that tells us a rough distribution, right? So it tells us lots of people are not that confident. I'm hoping after today you feel a little bit more confident. Like you can write some Python code. In fact, I think almost everyone in this classroom has already written Python. So hopefully confidence has gone up a little bit. And then maybe we're interested in, is there actually a relationship between your confidence in Python and whether you've taken a statistics class before? Potentially. So let's write another code cell. So I'm interested in the relationship between two variables, x and y, which we're going to turn to in part 2. But I just want to show you an example of a scatter plot. We have S and S, and then let's do scatter. We'll define the data as data. And then let's say we want the x variable to be how much did you like your statistics class? So we'll put this as the x variable. And then the y variable is going to be how confident are you in Python? So I have a weak hypothesis that there's going to be some relationship here. This figure is going to be a little bit difficult to see, but it will at least give us some picture of this relationship. So for those who are confident in Python, almost all of those people have taken a statistics class before. Beyond that pattern, it's pretty difficult to see what's going on. We can see that there aren't many people who hated their statistics class but love Python. If you hated statistics, then you're almost certainly not that confident in Python. So it gives us a little bit of a sense. But because this is discrete numerical variables, we have these points that are sitting on top of each other. This is actually me. I'm very confident in Python, and I hated my statistics class. So I'm a real outlier in this room, I guess. Okay, so I wish we had a little bit more time. I should have left a little bit more time for this. Your homework assignment is to go through and classify each one of the variables I've listed on the homework assignment as the variable type. This should not take you more than 5 to 10 minutes. So open the data set up, play around with it, and I will see you on Tuesday. Yeah.
So I was trying to do the survey part, like just to get the CSV in the Python
Okay.
notebook, but it showcases me an error. How do I make sure that the Excel?
Yes. Can I scroll around a little
Oh
bit?
yeah, of course.
Oh yeah, because this file path is not the same one as. So this is looking in the wrong location.
Oh.
So if you want to open. The class visualization. You can go to the website. Can I click around? And then if you open this notebook, that'll actually have the right location. So I put them in the notebooks because it's kind of hard to find
No,
where they are.
yeah, great. I should have just opened the notebook with the survey part. Okay.
Yeah, that'll give you the right
So
the
this
right
is the
location.
file path for that one.
That's right.
Okay, great. Thank you so much.
Yeah.
Where do we turn the collab link out to? Do we just email it to them?
Because I'm also.
So you don't have to declare codes.
Okay, so just on our own to figure it out.
Yeah, and then you'll just enter what's required in the in Grayscale.
Okay, that's right. Yeah, because I was looking at the notebook and I wasn't like, because there's like a homework notebook.
Yes.
Yeah, section. I wasn't sure.
Yeah, that's just for you to
Play around with it.
Oh,
okay.
Like the summary.
Oh, okay. Yeah, just answer the questions.
Okay. Exactly. Did you were trying to get it?
Yeah, I got it.
Nice.
Yesterday.
That's lovely.
Yeah,
Yeah.
it took a while, but finally.
Yeah. Good.
Thank you. I did, yes, yeah. We'll do, I have a class from like 1 to 15, I thought it's not science.
Oh yeah. Just missed it.
The next one, yeah.
Yeah.
Yeah, totally, sounds great. Okay, cool, yeah. And then at some point, it's a psychology class, but it's up at Skate Hall or whatever, by the Petersons. But I should be able to if I have an issue to this section that's going on right now, I can probably miss for 30 minutes while lecture there. Not too worried about it.
Okay. Yeah.
But there's also a lecture on completely so.
Don't feel too much pressure.
That's it, yeah. This is nice ones. But I'll do a campus announcement as well.
Sounds good. We'll walk up together in a second.
That's great.
Hello, Taylor. My name's Luke. Nice to meet you.
Luke, yeah.
I just had a quick question. It's probably a bit of a dull one.
Okay.
Because I was looking at the data set, and obviously all the entries for the mileage were rounded to a whole number.
Yeah.
But because it says approximately, would it be discrete? Because mileage can be continuous.
Yeah, so this is one of those places like the distinctions are in some cases pretty fuzzy between the different, especially numerical variables.
Right.
This one I would say because we measure it with like a ruler, like really big rulers.
Mm-hmm.
I would say it's a continuous numerical variable.
Okay.
Even though we're kind of recording it as.
Okay. Yeah, I was looking at the word approximately for a bit. I was like, don't overthink it. So I figured I would ask. So.
But I'm going to count both of those as correct answers.
Perfect. All right. Thank you very much. Nice
Yeah.
to meet you.
You too.